All right, so the first equation is 2x plus y equals -14. And I'm going to write these side by side as we go down here. Okay, so this is number 1. And the other equation I'm going to put over here next to it, and I'll explain why I'm doing them side by side in a minute, is -6x minus 3y equals 18. So let's say that you've worked through this, right? And you've decided through all your calculations that the correct answer, the solution to this system, the place where the lines cross, where x and y are the same for both systems, is the point 2, 18, right? And you're ready to submit and you're thinking, this is it. But wait a minute, I'm not totally sure this is it. So what can I do to figure out whether this really is it before I hit submit, right? Well, here's how you can do it. If I know that this is x, or I believe this is x, and I believe this is y, what I can do is I can go back to my original equations and I can substitute in my x and my y values for the x and y's in my original equations in the system and see what happens. So let's try doing that a minute. Let's see what does happen. So we're going to say this is x and that's x. So a couple things. When I do, this is effectively substitution, right? That's the same thing we've been doing all along. So we say 2. I like to use parentheses. Parentheses keep things very clean. In fact, you could just write the whole equation like this with those holes and then fill in the holes, right? And let's do that a minute. Let's just try it that way. Let's just write out the equations with the parentheses, making those nifty holes, right? And then we can go back and fill in to the holes. Because what I often find is people make mistakes because they're trying to write less or they forget to write something. This way, you just take this and plug it into the hole. Now, it is important to remember that the holes, you have to make sure you know which ones they are. So this is my x hole, and I'm going to substitute my x value there. And here's my y hole, and I'm substituting my y value. And while we're at it, I'm going to do it for the other one as well. So there's my x, and that makes this my y. Okay. So now let's work down through the next layer. 2 times 2, that's pretty easy. They're both positives. 4. Now I need to bring down something here. I have a positive sign and a negative sign. And this is why I like using the parenthesis. Because what some people might have done on accident was just put in an 18. Or they might have forgotten to write this positive sign because they knew they were writing a negative sign and ended up just writing -18. But when you use the parenthesis, you end up with 2 signs separated by that parenthesis, and then you realize you need to resolve this situation. So a positive and a negative gets me to a -18. And we just bring down the other side and we get -14. Now I'm going to finish working through this side before we go to the other side. So now I have 4 minus 18, which gives me a -14. And then on the other side, I have -14. So that's accurate, right? This is a true statement. Now, if you recall before, we've talked about this word true. And really, when we were up here and we were looking at this, we were trying to ask, is it true or false that this is the solution to this system, right? Is this true? Is this the solution? And here we're finding out that for this equation, at least, it is a true statement. It is a true statement that this is the solution to this. So now some of you might be thinking, oh, well, that must mean we're good. But there's a reason why I wrote them side by side. You cannot just check one. You have to check them both. It has to be true for all of them, right? Because it's entirely possible that this is a point on one of the lines, but not the other line. And you need a point that's on both lines because it's where they intersect. So let's go back over here and work. I had a -6 and a 2, gives me a -12, a -3 and a -18. And remember here, this is kind of like distribution, right? I need to distribute the whole -3 in here. So a negative and a negative tells me my sign is going to be positive. And of course, algebra students that you are, you can pull out that calculator anytime you want to work out 3 times 18, or you could just do it in your head and say, I know 3 times 20 would be 60. And so if I subtract 6-ish, then I get 54, right? So it's plus 54 equals 18. So hopefully people are starting to see a problem here. Okay, so I see the question, how did I know to change the 18 to a negative 18 once I put it as a coordinate? So it was a negative 18 here to start with. And I substituted it as a negative 18. So I haven't changed it at all. Now this side was 18 to begin with because that's what the equation said. But I haven't changed my negative 18 at all. It stayed that way when I substituted it. I've just changed it to a positive 54 because I had a negative 3 and 2 negative signs. A negative times a negative makes it a positive. But now I think hopefully we're all noticing that 54 and negative 12, that's going to be way bigger than 18. In fact, it's 42 equals 18. So if you recall last time, we had that special sign that we used when we got to this point and we had written equals and we realized it wasn't true anymore. And we took a diagonal line and we drew it through our equal sign. This is a clear way of telling yourself that you know this is not a true statement. And now remember our question was, is this solution, is it true or false that this solution satisfies this equation? And the first equation said, oh, that's true. But now we're finding an answer that is false. And they both those answers matter. So I'd like you all to kind of look at this and think about it. And then I'd like to get some feedback from folks. And how about, think about it for a couple seconds. And then Maya, Gregory, and Tina, I would like the 3 of you to give the class some feedback, either aloud or in the group chat, and give us some feedback on what you think. What does it kind of tell us if we get an answer that looks like this? What could we know at this point? How could this help us?
It tells us that one of the points isn't correct.
So one of the points, when you say one of the points, do you mean either the 2 or the negative 18?
The negative 18.
Ah, but you think the 2 could be correct?
Yeah.
Okay, all right. Tina, what do you think? Well, I'll come back to you in a minute, Tina, because I'm seeing from Maya, her answer is that it lets you know that one of the y coordinates isn't correct, and we need to fix that. So she's saying that the y coordinate isn't correct as well. Would you agree with them, Tina, or do you have a different thought? Okay, well, maybe we'll get some input from Tina a little later, but the thing about it is, if you did your computations more, you might be able to figure out if one of these was correct. But really what this is telling you is that as a set, as an ordered pair, this is wrong. This doesn't necessarily tell you that one of them is right. And it wouldn't necessarily tell you which one of them was right. What it tells you is as an ordered pair, it's wrong. So you need to go back to the beginning and try again. Okay, so I don't think you could say safely, although it might be true in this situation, but it wouldn't be safe to say that the x value is right and the y value is wrong, or the y value is right and the x value is wrong. You wouldn't really be able to figure that out for sure until you went and reworked the problem. It might be in this problem, just circumstance, just as circumstances make it that this one is correct, but don't take that to be true all the time. That's not necessarily a safe pattern to follow. All right. So if we have a false and a true, if either of them is false, then you know that this is not, as it's written, a correct, true solution to this system. So let's look at another one. And this problem may look a little bit familiar. All right. So we'll call this number 2. That should look a little familiar there. All right, we just saw that recently. And the other equation we're going to use is x minus 3y equals 5. And so here I want to find out, is it true that -1, -2 is a solution to this system? Is it true? Right? I'll just write that here. Is it true that that's the solution? So let's start substituting in our equation here. We have 1/3, and that's where our y value would go, and 7/3, and then our x value, plus 5/3. And another equation, we have where our x value will go, -3, and our y value equals 5. And now we can substitute. Now here's something you really need to be careful about, and it is a possible pitfall of doing it this way, of writing it, writing your parentheses. Here we have our y first. And so maybe you're going to go, oh, well, I'll put my y first. But then I go over here and if I put my y first, well, that wasn't the first one. So you need to be very careful about which ones you're linking up with which ones. Don't just assume that, well, I generally see x first and then y because it's standard form, or I generally see y first and then x because it was slope intercept, right? So just make sure that if this is y, you're putting in the y value. That's a common place to make a mistake. So I put -2 here and -1. And in my other equation, I have my x value first. So my -1 goes here, and then my y, so my -2. All right, let me move this up so you guys can see more of it. So working out the math, we get a -2/3 equals -7/3 plus 5/3. And on the other side, we get a -1. Now here we had 2 negative signs, so a -3 times a -2. Remember, that's the power of using our parentheses. It helps keep things organized. So a negative times a negative is going to be a positive, and 6 equals 5. So you guys work through that next step and see what you get on the math here. I'll give you a few seconds to work through that on your own. And as you're working through it and thinking about what the results are, Taryn, Noah, and Jackson, I'd like to get your feedback on how we interpret the results we're going to get. So I'll make sure you know what the results are, that we have them correct. Although if you'd like to volunteer on your own, you certainly can. So hopefully we've all brought down our -2/3 on this side and our equal sign. And the -7/3 plus 5/3 gets us a -2/3 here as well. And that statement then would be a true statement. In our other equation, we have a -1. We're adding 6, and that gets us a 5. And the other side was 5. So here we also have a true statement. So Jackson, Noah, and Taryn, what do you guys think that might mean? How do we interpret this result?
I think both sides are true. Yeah, I think that both sides are true because it equals the same thing on both sides.
Okay, so you're seeing pairs of equal constants, and that gets us to true. Okay. Do you have any thoughts, Noah? So what do you think, Noah, about what does it mean that they're both true? If the first time we talked about it and we had a true and a false, but this time we have two trues. So what might the difference be? And if you want to take a crack at that part, Jackson, go right ahead. If anybody else has an idea, go ahead as well. Okay, well, let me explain a little more then. So on our first one, we were asking whether this is it true that this was the answer? And the first time we said, yes, it's true. And the second time we said, no, it's not. And so this no, it's not, if there's any falses, it's not. But here we asked, is it true? And we said, yes, it's true. And then we said, yes, it's true. So this is the solution. So a way you can show that is you can use a check mark next to it. You can say, yes, this is a solution, right? I have two true responses. This is a true statement. Up here, I had a true statement and a true response and a false response. So this was a false statement. All right, let's try another one and maybe it'll get a little clearer. So let's go for number 3. And for number 3, our two equations are going to be y plus 3x equals negative 13. And our other equation is going to be negative 2x plus 5y equals negative 54.
Mrs. Flood, can you move it
I
up?
can move it up. Yep. Thank you.
Yep, perfect, thanks.
All right, and now we're going to ask, is it true that negative 10, negative 1, negative 1, negative 10 is a solution? So let's start substituting this into our equations. And I'd like you guys to take a crack at this on your own, right? So remember, let's make I'll start it off for you a little bit and you guys can pick it up. So we're going to put our parentheses and our addition sign and our 3 and our parenthesis and our equal sign and our 13. And I'd like you guys to kind of take it from there and I'll give you a minute or two to work through it. And just so folks know who's going to be asked for feedback, as you're thinking through it, Addison, Cameron, and Georgia, you guys can give me some feedback on either the math that you did, how you solved it, and then also, what do you think the solution means? And maybe you know how you solved it, but you're not quite sure what it means, and that's okay too. So just whatever feedback you have on what you found out.
Mateo, can you send that to Mrs. Flood? Thanks.
Nice. Was that on both of them, Mateo? Ah, okay. Let's see what happens with the second one. Yeah, if anybody else wants to send me a chat and let me know what you found, I'd love to hear it. Yep, Ethan, I see that. Yep, I would agree with you, Nandika. So hey, Cameron, I'd like you to start us off if you would. If you can just help us work through the math on this first one and tell us how you solved it. You can either do that in the chat or you could do that aloud. What do you think? So my question, Cameron, is how did you solve this first equation? What did you find as an answer, and what did you think the result of that might mean? Did that make sense, Cameron, or is the lagging too bad for you? Okay, it sounds like maybe Cameron's having some troubles. Addison, do you think you could help us out?
Yeah, so do you want me to give you the answer or how I did the problem?
Can you walk us through how you did it?
Okay, so I replaced y with -10 and x with -1.
Okay,
And-
kind of like that.
Yeah, and
Okay.
then you do that, you get -10 and -3 equals -13. And then you
Okay.
already know that it's going to be -13 equals -13.
And how do you interpret that result?
It's true, but we don't know for the second problem yet, so.
Ah, okay. So we need to wait a little bit to find an answer to our question. Okay. So Cameron, can you help us with the second one? Is it coming through any clearer now? Hold on a second, Cameron. Hey, Georgia, do you think you could help us out? It seems like Cameron's having some difficulties with tech today. It's okay. Whether you got it right, it's not the issue, but let's see if we can walk through the process together.
Okay, what I did was I first set up the equation, so -2, and then in parentheses, -1.
Okay, because that was your X value. Good.
Yeah, and then plus 5 in parentheses, -10
Okay.
equals -54.
Okay. And where'd you go from there?
And then I kind of simplified the left side, so I got -3 plus -50 equals -54.
Okay, so I would agree with you on the -50 side. Over here, if it was a -2 and a -1 though, when we're multiplying them, our negative times our negative gives us a positive sign, and our 2 times 1 gets us a 2. So we would have 2 minus 50 equals -54, but you were really close. So can you take us that next step?
And then it would be -48, I'm pretty sure.
Uh-huh.
And then it does not equal -54.
Good. So we're going to use that nifty slash there. So how do you interpret that result then, Georgia?
That it's not true.
That is not true. Okay. And I'm going to use the word false. Not true is another way of interpreting this. So what do you think, Georgia? If we had a true the first time and a false the second time, how do you interpret that for our question?
I don't really know. The first question would be true, but I don't think about the second one.
Okay, so here's another way you could think about it. This is kind of maybe a silly analogy, but you're out shopping for clothes and you're looking for a new dress or a new shirt, and you're thinking to yourself, well, I need one that's white and it needs to have long sleeves, right? That's my X and Y variable for my shirt. It's got to be white and it's got to have long sleeves. Well, if I find a shirt that's blue and has long sleeves, is that going to solve your question?
I don't think so, no.
It won't, right? It's not what you were looking for. It had to
Yeah.
be white with long sleeves, and you found blue with long sleeves. Or if you found that one that was white with short sleeves, that also wouldn't solve your problem, right? So you
Mhm.
have to have, both of these have to be true for it to be a correct solution. Does that make sense a little bit?
Yeah.
Okay. So if any of the things you're trying to prove are false, then it's false overall.
Okay.
It doesn't fix your problem. Okay. So we're going to try one more, and have you guys work this out on your own. And then I'm going to ask for some folks to help with the answer for it. Okay. And I'm going to do it on my other side of my paper over here. So number 4 is 3y equals negative x minus 3. And the second one is 3y minus 4x plus 12. I'm sorry, equals. I apologize. That should be an equal sign there. 3y equals negative 4 plus 12. So make
Mrs.
sure you don't lose that equal sign in there.
Could you slide it over a little bit?
There we go. Sorry about that. And the question is the point 5 comma negative 2, is that a solution for this system? So is it true that this is a solution? Okay. That's what we're trying to find out. So I'd like you each to work through that on your own. And then just so you can be thinking about it, Ethan, Natalie, and Nandika, I'd like to get some feedback from you on how you interpret the results that you come up with and how you got there. And, if someone's having technical difficulties, that's totally cool. Just send me a chat, and maybe we can do it through chat, or maybe we can redirect to somebody else if you're having trouble. I see your response, Ethan. We can talk about that in a minute. I'd definitely be looking for your feedback. I like the question, Ellie. Maybe you could ask that again in a minute. It's a very good question. Well, hey, Nandik, I see your text there. Do you think you could start us off and help us work through number 1?
Okay. So first you have to write the equation, but instead of the y and the x, add parentheses.
Okay. So I've got 3, and then what do you want me to do next?
Parenthesis.
Okay.
If we're gonna add the 5 and -2, then you have to add -2 right there.
Okay, so because we're multiplying -2 in place of y equals
-5 or negative
okay.
parenthesis 5.
Yeah, so I would put the negative out front because we're substituting directly for x. And there's our 5.
-3.
Okay.
And if we solve that, it would be basically it would be -6 equals -5 minus 3, and -5 minus 3 is -8, which is not equal to -6, making it a false statement.
Okay. So, hey, Ellie, could you ask that question again aloud maybe, or to the whole group in a chat?
Yeah, so since the first problem was false, do we need to even start the second problem?
Why do you think maybe you wouldn't need to?
Because if we already know one of the ordered pairs is wrong, then why do we need to know the other one's wrong?
Right. You're absolutely correct. If you already know that this solution doesn't work in your first one, then it doesn't matter if it works in the second one, does it? Right? If this is not a true statement for the first equation, then it's not a true statement for the entire system. Does anybody have any thoughts on that? But I do have to ask you, how often do you think we're going to be that nice to you? You know, giving the first one false and the second one, you know. But anyways, so, but just for practice, I'm going to walk through the second one. So Ethan, can you help me through the second one?
Okay.
So what do I write next? How do I do my solution for the other one?
3, then parentheses -2.
Okay.
Then equals -4 parentheses 5.
Good.
And then plus 12.
Okay.
Then 3 times -2, which is -6, equals -20 plus 12. And then -20 plus 12 is -8, so that leaves -6 doesn't equal -8.
All right, and there's our not equal sign. So our result then here as well is false. So if it had been true though, Ellie would still have been right that you didn't need to solve for both of them once you figured out the first one. But I wanted to make sure we went through the second one so you got the extra practice and you could see. So if either of these are false, your solution is wrong. So I do have to ask though, great, so now what? I checked my solution, I got a false. What am I supposed to do now? What do you guys think? What should I do at that point? Remember, I'm trying to take a quiz. I'd like to pass it. I just found out that my solution is false. What do I do? Yeah, Ethan says you got to try again and get a different pair. He's right, right? Yep, absolutely, Cooper, redo. Now, and remember what I said earlier, it may be that just by coincidence, either your X or your Y value in the first solution was correct, but that's coincidental. You shouldn't assume, well, one of my answers was true and one of my answers was false. So that must mean that one of my coordinates is right and one of my coordinates is wrong. There's not a correlation like that. If it's false, you need to assume that the whole thing is wrong and start over, not just say, oh, well, one of them must be right. I've got to figure out which one it is. Okay. Does anybody have a question or another thought before we go on from here? And I can zoom out if anybody wants to see the whole sheet at once, just if you want to, kind of check what the whole deal was and to see everything at once. All right, so remember, our purpose in all of this was to figure out how to check our own work. It's something that mathematicians really need to be able to do, because when you're doing your own work, it's not like there's an answer in the back of the book necessarily. And honestly, if you think about it, the back of most textbooks only have half the problems, right? Conventionally, all the odd numbers are in the back of a textbook, but the even numbers aren't there. So if you want to be able to check your own homework and know for sure that you got it right, being able to check your work this way is good. Now, can anybody think of another way you could have checked these? Like, are there any tools at your disposal that you could use? Do you remember we kind of put these into calculators and you could maybe solve it with a calculator by graphing, right? So you can, if you did your answer by substitution the first time, you could go back and validate your answer using a calculator and graphing. Now, this may be easier, but it might also depend on how complicated the equation is. Right now, you don't have any exponents on your X's and Y's, but as equations get more and more complicated, you might find that putting it in and graphing it would give you a faster solution than this. But for now, this is a really safe way of making sure that you get every problem correct, because you can check the solution for yourself.